important pillar of Industry 4 is simulation. A simulation is an approximate imitation of of operation of a process or a system that represents its operations over time. Simulation is used in many contexts, such as simulation of technology for performance tuning or optimizing, safety engineering, testing, training, education, and video games. Simulation has been used in Industry 4 and which has revolutionized how the industry work and optimize their processes. In this video presentation, we will learn about what is simulation, what role does simulation play in the Industry 4, and what are the applications of simulation. We already know that Industry 4 is driving things forward in a very fascinating way. One of the technologies which has given its fair share to the wonder of the Industry 4 is simulation, a computer model which can mimic the operation of any real or suggested system. Perhaps the best way simulation can help an organization is to estimate better the return of investment before it actually initiated. It's another enabler for improved decision making, and needless to say, it helps companies both save and earn more money. How does it happen? Well, the main reason for a simulation process can achieve such result is that it can account for the behavior of individual tasks and resources by measuring what will happen in the manufacturing system over a period of time. Simulation is also preferred because of another important feature: it is risk-free environment. So what is simulation? It is a computer model which can mimic the operation of any real or suggested system. Perhaps the best way simulation can help an organization is to estimate better the return of investment before it is actually initiated. How does it happen? Well, the main reason, as I said, is the process can achieve results. An example on a simulation: let us say your company receives a large production order which needs to be done in a short amount of time, and because of the process intensity, a machine breakdown, or you identify another problem within the production line. This is where simulations come in handy. It can help you find out such weaknesses in advance and reduce equipment downtime by testing ways to limit its impact, and also making it easier for engineers to design a more efficient manufacturing line. Let us see through a video presentation what is simulation in an assembly line.
Simulate is the simulation tool of choice for the world's largest and innovative manufacturing organizations, including Ford, General Motors, Siemens, Cameron, and Kroger. Our vast manufacturing user base and experience with manufacturing users means we understand what is important for manufacturing engineers and the key stakeholders involved with process improvement. Let's look at an example. This simulation is set within an assembly line where multiple families of electric motors are produced. The purpose of this simulation is to see how we can increase the throughput of our current production line based on the production schedules feeding the line. As the model runs, you'll see different colored balls. These represent various products moving through the line. Time is shown on the clock, and the number of finished goods is represented by the throughput number on the screen. Let's look at some of the inputs feeding the line. For the purpose of the simulation, we will change the production schedules and view the impact of increasing the demand. You can also change other variables using this interface, such as the processing times for the machines based on the product type. You can also control the changeover times for the different machines based on the product type in the system. Other inputs to the simulation are the line operators currently working within the system and responsible for specific areas. Let's run the simulation to the end and check out some of the results for the 4-week period. Moving the speed bar to full shows how fast you can get access to those all-important results. Now it's Friday, week 4. We can see the throughput of the system is 619 finished goods off of the line. To examine some of my results, the simulation is pre-populated with various KPIs. These are the important KPIs I want to report on. The types of measures available to analyze are things like units per hour, average time in the system, resource utilization including operators, and utilization of equipment. So this brings us on to some what-if analysis. I want to change the input schedule to increase the demand for products. Previously, the system was using production schedule 1. Now we'll switch to production schedule 2. By running the simulation again, I can now test out these new scenarios and compare KPIs. Feeding in extra work increased throughput to 817 finished goods. The simulation shows you instantly where your bottlenecks exist, and it's clear in the simulation that we have a large bottleneck before the winding stations. Let's do some more what-if analysis. An increase in demand means your system is going to struggle, so the obvious thing to change here is the number of winding cells. Let's select these and create additional winding machines. The simulation will now run with double the capacity. Interestingly, by increasing the capacity, we have in fact reduced the throughput. There could be a number of different reasons for this happening. If I look at my KPI dashboard in the Results Manager, I can see that the winders are nearly 100% utilized. What would happen if we changed the number of winders? We will recruit another member of staff on that shift to see. The throughput has now increased to 839. However, we have shifted a bottleneck to the oven area. So did we actually require the extra winding machines? These could have cost around $1 million per machine, a potentially large investment. Let's take them out. This is an example of cost avoidance and strategically placing resources within your system. We have managed to maintain the throughput level, so we actually didn't need those extra winding machines. We could have bought them and spent $3 million, but by using the simulation, we can see that we don't need to. By using the simulation, we were able to make the most cost-effective decision to drive the throughput of our assembly line, and that decision was to employ an additional member of staff at our winding area. This is just one major benefit about testing your what-if scenarios within simulation before implementation in your real-life system. That was a simple introduction on how you might use a manufacturing simulation to quickly experiment with different scenarios, allowing for data-backed decisions.
Let's look at another simulation example of a video and how it integrates with the cyber-physical system. In the previous video, we saw a what-if analysis. By changing certain parameters, we could predict how much will be our production and how much will be the things will be affected along the production line here.
In connected industry, any adjustments to the production process functions can be tested in virtual simulations. If successful, they can be quickly and seamlessly implemented into the actual production line without any physical adjustment. Even large-scale reconfigurations are possible and easy. New functions are virtually tested, and then the new modules are quickly integrated in the real production line. It's all possible with open standards.
So what are the advantages of using simulation in the industry? It reduces the waste in time and resources and increases the efficiency in manufacturing. It helps increase the productivity and the revenue. Simulation has a significant role in the design of products. You can, before actually manufacturing them, you can simulate how the products will look like. Furthermore, as the complexity and technology increases, skilled workers required by the industry can be trained using the simulation exercise. It is using, like we have flight data simulators, aircraft simulators, the battle simulators. Similarly, it can be used in the industry and the manufacturing processes. Additionally, work safety issues are more important than it was in the past with the emergence of autonomous machines in the manufacturing, because then we are dealing with robotics and the machines there. We can actually simulate the safety issues and find where we need to bring in those safety factors here. The data will help create smartness and intelligence in manufacturing, and simulation helps in data analytics, in comprehension and knowledge extraction. So we have seen how simulation can help in Industry 4 by reducing the cost and optimizing our resources. Thank you.